Welcome back, and here we are actually going to do the soldering for the circuit for the Upsilon class shuttle. The first thing I did was cut off some of the unused pins on the AT-Tiny85. Now, you can only do this once it's been programmed, since the ones that I cut off are the ones actually used for programming. I also bent some of the legs out because essentially I'm going to have to create more or less a three-dimensional circuit, since I have parts that may overlap and might short circuit unless I make sure that they essentially are insulated from each other. Soldering the components is pretty easy. You just tin each of the components with a little bit of solder and then use a little bit of heat to join them together. You also want to make sure that all the components are trimmed so that they all fit together. I started with all of the resistors and worked my way outwards from the AT-Tiny85. Having the trace of the fuselage is pretty useful because it allows me to make sure that all the components are actually going to fit inside of the body. Now, you may notice in the diagram that pins 3 and 4 have traces that cross over each other, and you really don't want those things to touch. A proper circuit diagram will usually show that there's a bridge that doesn't allow those two things to connect to each other. I'll show you how I solved that problem in just a second, but first I'm going to use flush cutters to trim away the post that's in the cockpit to make room for the LEDs. The resistors are actually the ceramic striped component inside of the wires, and it's not conductive, which means that the resistor ceramic can touch a wire and it should be okay. So you'll notice that in the case of the overlap, I've allowed them to overlap, but only where the wire touches the other resistor. If you're still worried about short-circuiting, you can use a thin layer of superglue to insulate each of the components. Since components in both the front and the rear of the craft are going to have to all reach the ground pin, I've twisted two pieces of wire together to create an extension of the ground pin that goes both forwards and backwards. Because my luck with superglue just isn't the best, I decided to use heat shrink tubing for insulation instead. It's somewhat difficult to work with in these closed loop connections because you have to thread them before you solder everything together, and then the soldering iron can actually heat the shrink tubing and then cause it to shrink somewhere where you don't want it to. The next thing I did was solder the LED to the ground pin. By doing one leg at a time, it allowed me to clip the legs down from both the resistors and the LEDs to the correct lengths before soldering them together. I repeated the process for each of the LEDs, adding a little bit of heat shrink tubing each time just to make sure that I didn't accidentally have any of the positive pins ground against any of the negative pins if the wires were going to overlap with each other. After all of the front LEDs that face the cockpit were attached, then I used my heat gun to shrink the heat shrink tubing. Now to work on the engine LEDs. I had to drill out the engine nozzles on the top half of the fuselage. I used progressively wider drill bits starting from the outside of the engine nozzles and working my way in before I was satisfied with the final diameter of drill bit that I used from the inside, working my way out. I also had to clear away some plastic on the back half of the bottom part of the hull. For this, I just used my flush trimmers. Since the two engine LEDs are connected in serial, I needed to make sure that they fit together inside of the engine nozzles at the correct distances, so I roughed them out, bent the wires into place, and then trimmed them and soldered them together. This goes without saying for most electrical engineers, but you need to make sure that the LED polarities are correct before soldering them together. Once I was certain that the engine LEDs fit inside of the engine nozzles at the correct spacing, then it was time to go ahead and attach them to the rest of the circuit. At this point, it's possible to hook up a power supply to the positive and negative pins on the AT-Tiny85 to make sure that the circuit is soldered correctly and does work. The next step is to drill a hole for the power pigtail. It's going to go in right behind where the base peg goes. You'll note that I did this step before I glued the circuit into the fuselage. I also had to trim the wires for the pigtail down to a small enough length to just reach the negative ground and positive inputs on the AT-Tiny85 controller. Before soldering the pigtail and gluing everything together, there was a few other things I needed to do with the plastic work. I used the Dremel to trim away a little bit of the bottom half of the cockpit to allow some more of the light to shine through. These gaps will be filled in with a diffuser made out of silicone glue. Once the plastic work on the bottom half of the fuselage was done, I threaded the pigtail through the bottom half and then soldered the circuit onto the pigtail. You'll notice that the wires are running underneath the integrated circuit. They have to be pretty short, and therefore you have to be pretty careful when soldering them together, otherwise you'll run out of space. Once the soldering's done, you can use a little bit of glue to glue the chip down onto the base peg. At this point, I was able to use alligator clip test leads to connect a PowerBoost 500C to a male JST-PH connector. Now that everything's working, in the next video we're going to put it all back together and make a lens out of silicone glue. Thanks for watching!